What if a 90-year-old idea, one that physicists pretty much dismissed as a simple mistake, turned out to be the key to a theory of everything? Well, one physicist has spent the last 30 years arguing exactly that this mistake is actually the very foundation of our universe.
And it all starts with this feeling. This quote right here gets to the heart of what drove Professor Felix Finster on a 3-decade-long quest. As a student, he just felt like the physics he was learning was missing something real. To him, it felt like a bunch of clever tricks and patches, not a true description of nature.
So our story really kicks off with a dissatisfied physicist. Felix Finster's entire journey began with this nagging feeling that the very foundations of modern physics might be, well, a little bit shaky.
And look, the stakes here couldn't be higher. Physics is kind of stuck on some massive problems. I'm talking about uniting gravity with quantum mechanics, understanding dark matter, and explaining why our beloved standard model has more than 25 different numbers that we just have to plug in by hand. This is the exact landscape that pushes thinkers like Finster to go looking for entirely new foundations.
And this brings us to the heart of the story. Because Finster's radical idea didn't come from some brand new flash of inspiration. No, he reached back in time and resurrected a concept from the 1930s that everyone else had basically left for dead.
Okay, so back in the 1930s, the brilliant physicist Paul Dirac proposed something truly bizarre. To make his equations work, he said that the vacuum of empty space isn't empty at all. Instead, it's a vast, infinite sea of particles, all occupying these weird negative energy states. Now, as strange as that sounds, this wild idea led him to correctly predict the existence of antimatter, which was discovered just a little while later. But there was a huge problem. If you took it literally, the Dirac sea meant the vacuum had infinite energy and infinite electrical charge, which, just sounds like mathematical nonsense. So physicists had a dilemma. The idea worked. It led to a real discovery, but its foundation seemed impossible. So they made a choice. They kept the prediction of antimatter, but they dismissed the sea itself as just a clever mathematical trick.
And this is the question Finster dared to ask. While everyone else saw a problem to be explained away, he saw a foundation to build on. He thought, what if the infinities didn't mean the Dirac sea was wrong, but that our math just wasn't good enough to describe it yet?
Which brings us to a maverick's difficult journey. As you can probably guess, pursuing this idea was not easy. Finster faced some serious resistance from a physics community that really viewed the Dirac sea as a settled issue, a long-debunked concept. It was going to take decades of pure persistence to even be taken seriously.
As a student back in the 90s, his ideas were met with a whole lot of skepticism. So he made a really clever strategic pivot. He moved into mathematics. He found that mathematicians were just more open to building entirely new structures from the ground up. And for the next 2 decades, he put his head down and worked, building the rigorous mathematical tools he needed to turn his gut feeling into a real, coherent theory.
Okay, so after all that hard work, what did he actually build? This is where it gets seriously mind-bending. His theory is called causal fermion systems, and it basically constructs our entire reality from the ground up, starting with almost nothing.
All right, let's break this down because it's a big idea. Forget everything you think you know about spacetime. Step 1. Imagine just a powder of disconnected, abstract points. There's no space, no time, no geometry. Nothing. Step 2, now you take all those wave functions from that Dirac sea we talked about, and you kind of sprinkle them across these points. Step 3, you apply a fundamental rule that Finster calls the causal action principle. You can think of it like a principle that searches for the most stable, most interconnected arrangement of all those wave functions. And step 4, the result? That optimal arrangement, that beautiful web of connections. That is what we experience as spacetime and cause and effect.
And this right here is the core takeaway. In this picture, spacetime isn't the stage where reality happens. It is the web of relationships between all the particles in that underlying sea. Fundamentally, reality is a network of information.
So what's the payoff for this totally radical new picture? I mean, if you're going to go and rebuild all of physics from scratch, you'd better have a pretty good reason. Well, Finster's theory claims to provide several.
This is basically the grand slam. The theory claims that if you zoom out to the large scale, you get Einstein's general relativity back. You also get the standard model of particle physics. It naturally predicts the 3 generations of particles that we actually observe. It even offers a mechanism for why there's more matter than antimatter in the universe. And on top of all that, it claims to solve the infamous quantum measurement problem. Any one of these would be a Nobel Prize-worthy puzzle.
And here is the kicker. That number 1 you see on the screen, that's the number of free parameters in Finster's fundamental theory. Just 1. For comparison, the standard model of physics has more than 25 of these, numbers that we just have to plug in by hand, with no real explanation for why they have the values they do. The hope here is that all the complexity of our universe arises naturally from this much, much simpler foundation.
Which leads us to our final and maybe most profound thought. Is spacetime just an illusion? This theory really challenges our most basic intuition about the world, suggesting the familiar fabric of space and time might not be fundamental at all.
This leaves us with a huge final question. What if space-time isn't the stage on which reality plays out, but is instead built by the actors and their interactions? Finster's theory suggests space-time isn't the container for the universe, it's a consequence of it. And if that turns out to be true, it could change absolutely everything.